fifth session of acid, base and salt. In previous session we have discussed about pH scale, which was discovered by S.P.L. Sorensen. In that we have discussed that it will be between 0 to 14. Which numbers are nearly to 0? That will be acidic. The numbers which are close to 14, so that will be alkaline or basic. And 7, it stands for neutral. We have also understood that how pH is connected with our daily life. In that we have understood the sensitivity of animals and plants. In that, what is the role of pH? We have also understood that in soil, how pH is important. In our digestive system, what is the role of pH? Why we have to maintain it? In that we have also taken the concept of acidity, and we have also noted down about antacids. After that, we have discussed that why it is necessary to maintain a proper range of pH in mouth, and if it is not maintained, there will be tooth decay. And we have also understood that methanoic acid is produced from sting of nettle leaves and by bite of honeybee. In that cases, we have to apply the basic substance which gives us relief from it. In today's session, we are going to understand about salts. Generally, in the process of neutralization, we have understood that when acid reacts with base, it will give us salt and water. Now, actually, this salt will be of three types: acidic salt, basic salt and neutral salt. Let's see how. Suppose if I am having a strong acid and it reacts with a strong base, so in that case my salt will be neutral and its pH will be nearly equal to 7. We take weak acid and weak base, in that case also it will be neutral and its pH will be nearly equal to 7. If we have a strong acid and a weak base, in that case our salt, it will be regarding to the strong, and that is acid, so it will be acid, and its pH, we all know for acidic substance pH will be less than 7. And if we have a weak acid and a strong base, it will be basic, and for that pH will be greater than 7. So this way salt can be of neutral, it can be acidic also, or it can be basic also. Now let's discuss about the common salt. We know how the common salt is formed. It is formed by reaction of NaOH plus HCl, which results into NaCl plus H2. This is our common salt, and we know that how this common salt is formed. From the seas we are getting it, from the rock salts we are able to obtain it. This salt is useful for many work, like in our domestic, for a domestic purpose this common salt is used. Also it is used as a reactant in some of the industries, right? So common salt is also an important compound to know. In this session we are going to understand about some important compounds like NaOH, bleaching powder, and plaster of Paris, right? So acid plus base, it gives salt and water. Salt can be neutral, it can be acidic, or it can be basic also. How common salt is formed, that we have discussed, and from where it is obtained, that also we have discussed. We have also discussed about its uses for a domestic purpose, also as a reactant, also in preparation of baking soda, washing soda, and in many purposes it is used. And now let's have a journey on the preparation and uses of some important compounds like NaOH, bleaching powder, and plaster of Paris. So let's start our journey. So let's go towards our chlor-alkali method. Now, what is chlor-alkali method? See, actually in this method, we are getting chlorine and an alkaline substance, a basic substance like NaOH. So it is called chlor-alkali method. What we have to do for it, right? So let's see. First, we have to take a brine. Now, what is brine? Brine is an aqueous solution. Brine is a saturated aqueous solution of sodium chloride, NaCl. Now, when this NaCl, it reacts with water, aqueous solution of it, which reacts with water, NaOH, aqueous form, plus Cl2 in form of gas and H2 in form of gas. Here you can see that this is our alkali and this is our chlorine. So due to this process, alkali and chlorine both are produced. So that is called chlor-alkali method. Now, as we want to balance the chemical equation, how we can balance it? 2H2O. Right here we are having 2 hydrogen and 2 oxygen. So here we have 2. So this way, 2 mole of NaCl brine solution, when it reacts with water, it will give us alkali and chlorine both. So that is called chlor-alkali method. Now, let's see how this NaOH is formed. Here you can see that we have taken brine from this side. Brine means, as we have studied, that the saturated aqueous solution of NaOH is there. And water is also present there. Now, here you can see that the electric cell is arranged. Positive charge anode and negative charge cathode. When electric current is passed from the solution, what will happen? So as we have studied here that we will have NaCl and H2O both. So from NaCl we will have sodium positive ion and chloride negative ion. From H2O we will have H plus positive ion, OH minus negative ion. Now as we know that this positive ions will move towards negative, means it will go towards cathode. Here you can see that Na plus and Cl, Na plus and H plus both are going towards cathode. Here both of the negative charge Cl minus and OH minus, it will go toward the positive electrode, that is our anode. Now this Cl, it will get released by chlorine gas, and this H plus, it will also get released in form of hydrogen gas. Now this Na plus and OH minus will form our NaOH, which is removed like this out. So this way, this is the process of preparation of NaOH, in which we have taken brine and water, and by doing electrolysis process on it, there will be formation of NaOH, chlorine and hydrogen. Now, the form which is here of chlorine, that is diatomic. This chlorine is used for different purposes that we know. It is used as in water treatment to purify the water, in swimming pool, in PVC. PVC means polyvinyl chloride, in preparation of PVC pipes, in preparation of polyvinyl chloride pipes. Then it is also used as disinfectant in CFCs, that is chlorofluorocarbons, and it is also used in some of the preparation of pesticides. Here the hydrogen which is formed on your cathode, it's used as a fuel, as a margarine. It's also used in preparation of ammonia in Haber's process. The NaOH which we are getting, right, it will be used as degreasing metals in formation of soap and detergent. Also it's used in paper making industries and also in formation of artificial fibers. So see, here the products which we are getting, how they are used, that is also explained. So in exam, this particular question can be asked you in different way. They can ask you that write how NaOH is formed, or explain chlor-alkali process. So that way it can be asked to you. They can also ask you that where chlorine is used or where hydrogen is used and where NaOH, that is our sodium hydroxide, alkaline substance, it's used. What is called brine? So that is the aqueous saturated solution of NaCl, which is called brine. So this way we have completed our chlor-alkali. Let's talk about the another compound, and that is our bleaching powder. In chlor-alkali method or in chlor-alkali process, we have obtained chlorine. Now that chlorine we can use here. Suppose if we have a slate line, and when a chlorine gas is passed from a slate line, it will give us CaO, Cl2 plus again slate line, and from that slate line if chlorine gas is formed, right, chlorine we can obtain from chlor-alkali method also. So it reacts with slate line and it will give us CaO, Cl2 plus H2O, and this will be our bleaching powder, right? So how we can write its process? Slate line. When slate line it reacts with chlorine, or when chlorine gas is passed from the slate line, it will give us bleaching powder and water. Now, what is use of this bleaching powder? So generally we know uses of bleaching powder. So we know that it is used to bleach, as a bleach in textile industries, in linen, right, to bleach linen, to bleach papers, right, or paper pulps. Okay, so this bleaching powder is used as a bleach in textile industries, in linen, and also it is used as a bleaching agent to bleach paper and to remove the dullness from the pulp of paper. This bleaching powder, it is also used as a oxidizing agent in different chemical reactions. It's used as an oxidizing agent in different chemical reactions, and this bleaching powder is used to make water germ-free, right? So this way this question can be asked to you, that write a short note on bleaching powder or write preparation and uses of bleaching powder, right? So we can write the process, then we can write the equation, and then we have to write their uses. Then our another compound is plaster of Paris. Now, as we all know that plaster of Paris is also known as POP. How this plaster of Paris is formed? For that we will require gypsum, and when gypsum is heated at 100 degree centigrade, or it is 373 Kelvin, it will give us plaster of Paris. Now let's try to understand it. Gypsum, that is CaSO4 into 2H2O, right? CaSO4 will have a crystal of 2 water. Now when it is heated at 373 Kelvin of temperature, from here we will get CaSO4 into half H2O plus 1.5 H2. So here you can see that this was dihydrate and here there is only half crystal of H2O. So this is called hemihydrate of calcium sulfate. So plaster of Paris is hemi means half. Plaster of Paris is hemihydrate of calcium sulfate. So by heating gypsum at 373 Kelvin of temperature, we will get the hemihydrate of calcium sulfate, that is our plaster of Paris, and 3/2 moles of water will be removed from it, right? Or you can also have a opposite reaction, that the hemihydrate, and when it is crystalline with water, you can also get gypsum. Now you all have seen that where this plaster of Paris is used. So generally this plaster of Paris is used in making toys, in decorations, also it is used by doctors, etc. In many purpose it is used, right? So this question can be also asked you, like write a short note on plaster of Paris or how plaster of Paris is prepared. They can also ask you that write the formula of gypsum or plaster of Paris, like how plaster of Paris is formed, or how from plaster of Paris we are getting gypsum, right? So in many ways this question can be asked. Only the concepts must be clear to us, that how it is prepared and where it is used. In our textbook the reaction is like this. Whatever I have written as a product, it is as a reactant. That in textbook it is written CaSO4 into half H2O plus 1.5 H2O. It will give us CaSO4 into 2H2O. So according to the textbook it will be opposite, but here it is asked for preparation of hemihydrate. So I have prepared it from gypsum. That's why I have written the equation like this, right? So don't get confused between this reaction and the reaction of our textbook, right? You will also understand the crystallization and decrystallization. In that, this concept will be clear to you, that how this dihydride is converted into hemihydrate. Okay. So this way, in today's session, we have understood about different compounds like common salt, NaOH. We have also discussed about bleaching powder and plaster of Paris. So hope you have understood the topics. You will complete your homework and you will send it regularly. Now after this session we will have a very important session, in that we are going to understand about the concept and the preparation, also some chemical reactions and uses of washing soda and baking soda. So be ready for it. But before that, we have to complete our 5th session of acid, base and salt. In that, what we discussed, so just have a quick look on it. We have discussed about salts and we have also discussed about common salt. We have discussed about preparation of NaOH, uses of chlorine, hydrogen and uses of NaOH. We have also taken a look on preparation of bleaching powder and uses of bleaching powder, and at last we discussed about preparation of plaster of Paris and uses of plaster of Paris.